Most people still picture the AI race as a contest of smarter models and bigger training runs. That phase is real and ongoing. But for the companies pushing the frontier, the next big constraint may be far more elemental. Electricity. Not algorithms. Not just chips. Power plants, grids, and the physical infrastructure needed to keep the lights on at massive scale. Welcome back to Synthetic Politics, where we cover the intersection of AI and political power. This week, that abstract argument became a lived experience for millions of Americans. A massive heat wave sweeping across the United States is straining the country's power grid and water supplies, and it is testing public support for the rapid expansion of AI data centers. PJM Interconnection, the largest U.S. grid operator serving over 65 million people across 13 states, requested that data centers reduce their power draw during peak heat hours to free up capacity for residential and commercial customers. PJM projects it will be a full 6 gigawatts short of its reliability requirements in 2027. In Virginia, Henrico County, which has 37 data centers, asked schools to limit power usage during peak demand. In Austin, a city analysis found that some proposed data centers are seeking more than 5 gigawatts of power, which is more than the peak load for the entire city. The political backlash is now bipartisan. Data center projects have become lightning rods for politicians ranging from Senator Bernie Sanders on the left to Republican Governor Ron DeSantis on the right. Texas Governor Greg Abbott recently called for a ban on building data centers in rural areas. For years, competition focused on compute, better chips, larger models, top talent. That race continues. Yet as models grow and AI moves from labs into widespread deployment, a different limit is coming into view. Infrastructure. We are talking electric grids, transmission lines, substations, cooling systems, water resources, and the manufacturing base that supplies transformers and other heavy equipment. Industries that long predated AI are now central to its progress. The numbers are striking. According to Goldman Sachs research, U.S. data center power demand will climb from 31 gigawatts in 2025 to 41 gigawatts in 2026 and 66 gigawatts in 2027. That is more than doubling in 2 years. A new Gartner report puts global data center electricity consumption at 565 terawatt-hours in 2026, a 26% year-over-year increase, with projections exceeding 1,200 terawatt-hours by 2030, more than Japan's entire annual electricity consumption. Anthropic has estimated that by 2028, training a single frontier AI model will require 5 gigawatts of power, and that the U.S. AI sector alone will need 50 gigawatts of new electric capacity by 2028 to maintain global AI leadership. 50 gigawatts is roughly twice the peak electricity demand of New York City. And this is already showing up on ordinary people's electricity bills. The capacity price that grid operator PJM pays to guarantee enough generating capacity, a cost that flows directly onto customer bills, rocketed from roughly $29 per megawatt day 2 years ago to $329 for the year beginning June 2026. Data centers caused roughly 63% of that increase, piling $9.3 billion in costs onto everyday customers. Maryland residents alone are set to pay hundreds of millions more in power bills due to out-of-state data centers. The conversation has shifted from, can we build a better model, to can we reliably power and scale it? And the answer is increasingly uncertain. At least 75 data center projects worth $130 billion have been postponed or canceled across the United States, not due to lack of funding or chips, but due to lack of power. Kevin O'Leary put it plainly, 50% or more of the data centers that have been announced, he said, will not be built because there is no power on the grid. This shift is forging new alliances. Tech companies are now deeply engaged with natural gas and renewables for near-term supply, advanced nuclear projects including small modular reactors for reliable low-carbon baseload, and grid modernization and transmission upgrades. Firms like Microsoft, Amazon, and Google have announced investments and power purchase agreements in nuclear and other firm power sources to secure the energy foundation AI requires, rather than relying solely on strained public grids. Utilities owning about a third of U.S. nuclear plants are now in discussions with AI data centers about long-term electricity supply. But here is the bottleneck nobody is talking about enough. Goldman Sachs research estimates that roughly $720 billion of grid spending through 2030 may be needed to support data center growth. Transmission projects can take several years to permit, and then several more to build. And permitting for new power plants and high-voltage transmission lines can take over a decade in the United States. AI companies want gigawatts in a few years. The permitting process takes a decade. That gap is one of the most consequential policy problems in America right now, and it rarely makes headlines. This changes how we think about international competition. America currently claims almost 40% of global data center electricity use. The U.S. benefits from innovation ecosystems and private capital, but faces grid interconnection delays and regulatory hurdles in many regions. Other countries may leverage state-directed infrastructure builds or different energy mixes. The countries that resolve these physical and policy bottlenecks most effectively could gain lasting advantages in deploying AI at scale, not just inventing it. There is one important counterargument worth taking seriously. Some analysts argue that efficiency gains from newer, leaner AI models could dramatically reduce power requirements, making today's most aggressive demand projections too high. If models get significantly more efficient faster than infrastructure gets built, the bottleneck may shift back toward capability rather than power. That outcome is possible, and it is worth watching. But for now, ironically, in an era of rapid software progress, the hardest challenges may be physical: concrete, steel, wiring, and coordinated execution across complex systems. Every major technological wave eventually runs into physical realities. The Industrial Revolution needed rails and factories. The Internet era required fiber and undersea cables. AI may be defined by its ability to secure and scale the electricity that powers it. The next leaders in artificial intelligence may not be determined solely by the smartest researchers in the lab. They could be the ones who best master power plants, transmission networks, and the resilient infrastructure that turns computation into capability. The future of AI is being built not only in research centers, but on construction sites, in utility boardrooms, and across energy policy discussions. Is power the decisive new arena in the AI race? Or will efficiency gains change the equation before the grid catches up? Drop your thoughts below. If this breakdown was useful, hit like and subscribe to Synthetic Politics. We will be back when there is more to report.